welcome back everyone. So this next session is going to be a brief overview of the new developer outreach program that Khronos is beginning to develop called KITE. And we have Erik Noreke, who's the OpenSLES and OpenXAL working group chair, and who's been working with us on the KITE program to give an overview. Thank you, Erik.
As Neil explained earlier, Khronos has been working for 11 years to connect software to silicon and provide standards that enable developers easy access to the hardware regardless of who manufactures the hardware and what kind of system it's running. It's a safe forum for industry cooperation, but up to this point it has been an industry cooperation, and most of its companies working to develop the standards. And as we look at the members of Khronos, you'll notice that there are a lot of various companies. There's 120 members in Khronos, and only a few are academic institutions. And when we look at the ecosystem of standards for Khronos, we have a focus on the multimedia APIs, the multimedia functionality, but there has been an ecosystem developed for the industry, but to complete what the industry actually needs, we've been missing one point, and that is the current focus right now. And that's why we're introducing the Khronos Institute of Training and Education, also known as KITE. So what are the goals and the vision for KITE? Well, what we're finding is that developers are looking for some place to go to learn about our APIs. Educators are looking for somewhere to go for information on how to teach the APIs, how to teach the technologies that are supported by the APIs. So we're looking to create a collaborative working partnership with educators and educational institutions. This is to encourage courses that use the Khronos APIs to teach the Khronos APIs. Not necessarily to have a university course dedicated to OpenCL or OpenGL, but to allow educators the material they need to incorporate the APIs and the technologies in their courseware, which may cover parallel processing or advanced 3D graphics. We're in the beginning stages of setting up the KITE program, and because of this, we're actually looking for people's input, both from educators, educational institutions, and students who are interested in becoming certified. What is it that you're looking for? So when we look at KITE, there's two parts to it. One is the community website, which is open to the public, where people can go and download materials just like they can from our specifications. You can download the specifications free of charge. So people will be able to get the open and free courseware material. But to participate in the community website, doing peer reviews and so forth, you're going to need to become a member of the KITE program. We're also looking to have an educator certification process where educators can become certified in teaching the Khronos APIs, where institutions can have programs that are certified for teaching them, and that where we can issue certificates to students saying that they are proficient in the APIs. Why we're doing this is that with our APIs, we're looking to have a certain level of standard for the quality of the implementations, which is why we have the performance tests. And we're taking that concept to the students and to the educators so that when you go and you look at a Khronos certified course or a material, that it has a certain level of quality to it. So on the community website for KITE, we're going to have access to free materials. It's going to be the ecosystem hub for educations. It's going to link you to SDKs, tools. You're going to have access to samples and example code, so that you know how you'll have access to the things that you need to put together courseware. You'll have the notice boards for internships, projects, students' projects, competitions. There may be companies that decide to have a competition for students to submit solutions and share demos, coursework, and projects with other educators. There will be newsletters, reports, and interviews. And it will also be a forum for where educators who have and people who have written books and sell their books and distribute paid courseware. So the KITE website, this is what we're envisioning right here. However, it is still under construction. We're working with it. We're still trying to find out what is it that educators and students really need from the KITE program and from the KITE website. So if you have any input, we would appreciate it. This is for you as developers and for you as educators to really give us the input so that we can give you what we need. So if we take a look at the Khronos process and how it gets expanded with KITE. Today we have three different types of membership. We have academic members, which are academic institutions. We have contributor members, which are the industry at large, where companies become members of Khronos. And we have the promoter members, which are the board of directors. These all participate in the working groups. We have one working group per API. And they develop the performance tests, the ratified specifications, sample codes, reference cards, and so forth. When we add the KITE program, we're going to add an exam item pool and educator program so that the educational institutions can supply the industry with the engineers that they need, with engineers trained in the technologies that the industry is using. So through having certified educators, we can administer Khronos courses and exams, or Khronos courseware can become a part of a larger course. And we can also grant Khronos qualifications so that when a company is looking at resumes, you can list that you have a Khronos certification in OpenGL, for instance. So we've developed a process for how an educator or educational institution can become part of the Khronos program. The main idea here is that it's going to be easy access to the working groups. It's going to be easy access to Khronos information, where there will be different levels of membership. The idea behind it is it's supposed to be easy for educators and students to become part of the whole Khronos process. The benefits to the educator program is certification, both for students and for educators and institutes. Depending on your membership level, you'll have access to confidential material and be able to participate in the working groups, find out what the working groups are working on. One of the problems today is that educators do not find out about what the working groups are presenting in the next version of the specification until it's released to the public. The KITE program allows educators to actually participate in the working group, find out what the working group is doing, so that when a working group releases the next version of the specification, an educator, professor can have the course ready for that technology for the semester following. So that it's going to shorten the time between releasing a specification and having educational material ready for it. This is going to be developed, or the thought is that it will be developed through a peer review process, combining other professors. The working groups are going to participate in this process, so that the intent is that we'll have high quality material available. We'll have an online listing in the KITE directory for professors who want to advertise their courses, list courses. I have an OpenGL course. I have an OpenMax course, so forth. institutions will be able to list themselves as being an institution where their parallel processing program is focused on OpenCL. And as I mentioned before, you'll be able to sell premium courseware on the KITE site. This is a complement to the free courseware that's also going to be available there. When we look at the membership levels in KITE, we're going to have individual membership. And this is for professors and individual educators. Not all institutions are interested in becoming members, and there are some educators and professors who teach at multiple institutions. So the individual membership is suited to the individual professor who is interested in getting access to the material, getting access to the peer review process, and exams. And this gives you an individual listing on the KITE website where you can list you as an individual professor with your courses so that students can find you. The academic membership is the same academic membership that we've had all along. And this allows educators and researchers who want to participate in the working groups to join Khronos. So this is full Khronos individual membership benefits. You get to sit in on the working groups, find out what the working groups are working on, give input to coming specifications, and so forth. And finally, we have the educational and institution membership. And this is for university and educational institutions. It gives them full KITE access, and that gives them access to the Khronos confidential materials and working groups. It includes the academic membership. It gives you certification for the institution's professors, should they choose to do so. The institution and course listings on the website. So you can list your institution as a Khronos teaching, a institution teaching the Khronos APIs, and it's unlimited for the APIs and the versions. So with that, we want to ask you, does KITE meet your needs? Are we missing anything? And is there anything else that we can help you as educators teach Khronos APIs and the technologies that are supported by the Khronos APIs? Yes?
I have a question. Most of that is for college and institutions. Is that correct?
The question is for colleges and institutions. The KITE program is designed for anybody who is interested in teaching APIs. There's educational institutions that are private, there's educational institutions which are public. There are companies that participate in there are companies whose main focus is teaching courses, and they too would be considered educators.
Are there any plans for online classes or things that can get the information into the hands of younger users instead of having to have them be institution age?
Regarding online classes and courses, Khronos themselves have not currently any plans for developing online classes. It depends on what students are looking for, the feedback that we get, and what the working groups are willing to, the effort the working groups are willing to put in. The courseware is going to be available online, so anybody who's interested in downloading the courseware can download the courseware, work through it, and educate themselves in that way. There are no specific plans on having online courses from Khronos.
Thank you.
Any other questions? Yes?
We're talking about the certification. So what kind of certification exam that the educator will take?
So if I understand, you're asking what kind of certification can an educator get?
Yeah.
The intent is that you as an educator can get certified through your knowledge of the APIs and your courseware in teaching, so that as you teach the classes, it doesn't have to be a specific API class. Maybe that you're using the APIs and the Khronos technologies when you're presenting a greater problem, for instance, advanced 3D graphics. So you would get certified from Khronos in your knowledge of the API, for instance, OpenGL in that case.
So how does one proceed to get the certification?
So how does one proceed to get the certification? The certification program is currently under construction. We're taking input on how would you like to see certification take place. How would you use your certification? How can we make it easy for you to get certified and easy for you to use your certification? So that's really where we're looking for your input to find out how can we make this work for you.
So where do we give you the info? Is there a website or?
You can go to the Khronos website, www.khronos.org, and go to the KITE website through there. You can also catch us here after the presentation, and or you can email us.
Yes, info@khronos.org.
info@khronos.org. Any other questions? Yes.
For the developers, I hope a complete and good quality SDK can be provided for us to develop, for example, OpenGL, OpenCL applications. Because for now, I need to find some small tools, for example, GLEW, GLM, and other tools to help us to develop OpenGL applications. Can Khronos provide some complete SDK to help us?
So you're looking for a complete SDK
for example, the Qt SDK, something like Qt SDK.
Okay. Khronos themselves do not develop software or tools regarding the API. We are a standardization organization. So we develop the standards. Then the community will generate SDKs, and some of them are available online. I don't know exactly which ones are available for OpenGL. It's part of the ecosystem hub. The intent is that we'll have the ecosystem hub on the website that will point to the various SDKs that are available. But it's not something that Khronos themselves are intending on developing. But we want to facilitate you finding them.
I think maybe Khronos can combine all these tools into an official SDK to provide to the developers.
So you would like to see Khronos have an official SDK for developers. The problem with Khronos developing an official SDK for developers is that when you start looking at SDKs, they tend to become more platform specific. They tend to be operating system specific. And Khronos works with developing things that are platform and operating system agnostic. And like I mentioned before, an SDK will often involve developing software, and that's not really something that we do. We would be more than happy to link to somebody who develops them, or if you just want to start an open source project, we can certainly list the open source project even before it's finished on the Khronos website, and to assist you, giving you the assistance that from other developers should there be an interest. Any other questions? Okay, thank you.
Thank you, Erik. So next up, we're fortunate to have Tom Olson from ARM, who's the OpenGL ES Working Group Chair.
Thank you all very much. Good to be here. So as Neil said, I chair the OpenGL ES working group, and in my spare time, Director of Graphics Research at ARM in the Media Processing Division. So I'm going to talk about two things. One is what is happening with the working group today and the standard. Where are we in the economy and in the standards process? And then I'm going to spend most of my time talking about a technical issue, which is portability. Standards, of course, are all about portability, and in an ideal world, you write to the standard and your code runs everywhere. The reality is not so pretty. So anyway, OpenGL ES, what is it? It's the mobile version of OpenGL. It was designed starting with the OpenGL Spec, and which had grown over 10 years to become quite large and complex, and removing a lot of features that people were no longer using because they were out of date, there were better ways to do things, or features that were simply redundant. We had a design principle that said there should be only one way to do things. Pick the best one, the fastest, get rid of the others. So that way we get all of the functionality, pretty much, of desktop GL at the time. But the API gets much smaller, easier to learn, easier to use. So we were very happy with how that worked. There are two versions in the market. There is the ES1 family, mostly ES1.1. This is starting to go away, but it's still very present in the market. I am still carrying an ES1.1 phone, so it's still commercially significant. People are still writing new code for it quite a bit. The other one is ES2.0, which came out about 3 years later, and this is the modern shader-based version. It's actually an even smaller API because what was all fixed function in ES1.1, where there were, the API supported a model of a hardware geometry stack. In ES2.0, everything moves into shader programs. And so the API is simpler, but the complexity moves into the application in the shaders. ES 2.0, well, both of these have been extremely successful. 2.0 is now dominant, is mostly replacing 1.1, but as I said, there's a lot of legacy stuff around. But together they've become the dominant API for mobile devices. This is not guaranteed to continue. We have WebGL coming, maybe in the future, but it's absolutely written in JavaScript. But for today, OpenGL ES is it. It's been extremely widely adopted. My own company is selling as much into set-top boxes, automotive, as we are into handsets. It is dominant in smartphones as well, and there are many hundreds of millions of devices in the field. So it was kind of fun for me, because SIGGRAPH is a good time for the industry to do some philosophizing and think about what has changed, what is new, and where do I want to be in the future. So at every SIGGRAPH, I have given a talk about the state of OpenGL ES, and for 2011, I looked back a few years to see what has been happening every year at SIGGRAPH. In 2009, this is the slide that I showed to tell people what was happening. And what was new in 2009 was that you could buy a consumer product that had OpenGL ES 2.0. Before that, it was all 1.1. These products were early, there wasn't a lot of software for them, but they were available. And there was also an emerging ecosystem. So these two, actually, of course, the iPhone was the first one, and the other was, I'm sorry, I can't remember. It was a Palm device. Was the second device to ship with ES 2.0. There were also books coming out, which was exciting. Before that, there was nothing. The following year, we had gone from having a few devices in the market to where most devices that were shipping were ES 2.0. Including on the desktop, you could get OpenGL ES on the desktop through an extension called RDS2 compatibility. This didn't give you a pure ES implementation, but it gave you a version of desktop GL which could run all ES2 code. And there was also support in AMD drivers for creating a pure OpenGL ES2 implementation. WebGL had just begun to be developed. Of course, the standard is still not quite out, is it? Oh, it is out. Okay. And WebGL, if you didn't know, is a JavaScript binding of a language which is, or an API which is very, very much like ES2.0. It's intended to be the same. Because of the object model, they've had to change a few things, also because of security. But basically, it's ES2 embedded in the web browser. And of course, mobile devices were all using it. Content was beginning to appear. This image came from a tech demo that Epic had done just to show that a version of the Unreal 3 engine could run in ES2.0. But this was a demo, not a product. So this year, it's 2011, what has happened? It seems to me that this is the year that high-end content really arrives big time. So we've now got the Unreal engine, Unreal 3 engine is not only shipping as a tech demo, but games written using it are shipping. The Unity engine runs on it. ITTech 5 doesn't run on OpenGL ES. Those 16K by 16K textures are a little beyond what we can do. But the mobile platform is interesting enough that it is doing demos. The Rage demo is particularly interesting, actually works in ES 1.1 because John Carmack didn't want to limit his scope to just 2.0 devices. So you can do quite amazing things even in that. But as I say, it's very exciting. We now have a closed ecosystem where there's content which consumers want and will pay for, and so everybody from beginning to end now starts to make real money from this. And that's what we've wanted all along. So what does my group do? Well, we meet twice a week actually now. The main focus of our work for the past 2 years has been the next generation API. It is still not here, and I'm not allowed to tell you when it's coming. But we're working very, very hard on it. It is our top priority. One thing that's exciting now, as I said, we have Epic, we have Unity, we have IDE, all using this API. We're starting to get tremendous feedback from them about things they don't like. And that's the most valuable input we can get, is to know that Epic comes to us and says, if I just had this feature, it would make my life so much better. That's a huge win for us. And that's driving what we're going to do in the future. Another thing we're doing, one of our 2 weekly meetings is the Convergence TSG. This is a joint meeting of the OpenGL ES group and the desktop OpenGL group. What we're trying to do is make sure that if there are differences between our APIs, they're driven by real needs. It's very easy if 2 groups are working independently that you can get differences emerge which don't add any value. And we're trying to avoid having that happen. And we've done a lot to tweak the APIs going forward so that they're more similar and it's easier to write portable code. Because we'll talk about portable code later. And then finally, the other big project that we're running is thanks to the promoters and Neil, we've raised money to hire a professional consulting firm, Symbio, to greatly improve the conformance tests. As you'll see when I talk about portability, not all OpenGL ES2 implementations behave identically. And sometimes that's necessary, as I'll argue, but in other times it's not. If we make the performance tests better, we can make it easier to write code that runs on every implementation. We're doing this jointly with the desktop because the APIs are very similar, so we're trying to improve the conformance situation on the desktop as well. That's what I have to say about the ES group in terms of market today. Do you have questions about that before I go into this technical stuff? Yes?
The current OpenGL ES 2.0 performance test, I know you're working on a brand unified one. Do you have one already set up for just purely on ES 2.0? And also, more importantly, how hardware manufacturers, writers pay? What is their pay on that?
Oh, sure. This is something I should have said earlier. We have had a conformance test for the past 3 years. It is actually pretty good. It's just not good enough. The way the process works, all the members of my working group are members of Khronos. We're called either contributors or promoters. You pay a different fee and you have different rights, but we're all members. Anyone who wants to implement the API is welcome. But if you want to sell it or advertise it as an OpenGL ES implementation, you must certify conformance. The way you do that is you sign an agreement called the Adopters Agreement. So you're not a member, you're an adopter. It's much cheaper. In return for that, you get access to the conformance test, and you get the right to make submissions. So you build your implementation, you become an adopter, pay the fee, run the conformance test, and usually you will find bugs and fix your implementation so that it passes. And then you go to the adopter's website and you submit. So you run the test, it produces big output. You package it up in a zip file, submit it, and then there's a committee internally in the working group that reviews the submission and makes sure it's okay. If it's okay, then your implementation is certified as a correct implementation.
But going on that, how well is that being adopted though? How, as software developers in here, obviously we rely on a correct ES 2.0 implementation. As of today, we find that for some reason there may be QA lacking with certain manufacturers. The early phones might be really good, but then for some reason the newer ones has maybe taken a step back, and yet it's still 2.0 compliant.
That's interesting.
And what we get is an entirely different situation where, hey, it's crashing over there, and everyone says, well, it's not my fault, you know, it's the driver's fault or manufacturer's fault.
Sure. No, it's a very interesting problem. We have spent, am I allowed to say how much Khronos has spent? Developing tests is very expensive. We've spent on the current Grand Unified test about $300,000. And the test is much better than it was. It will never be perfect. And it is going to be the case, as I'll talk, and in fact I'm looking forward now, I'm glad you're here, because I'm going to talk about portability, but I don't write code every day for a living. So there are many things that you have probably seen that I have not. One thing that you can help us with, do I have this on the website? Sorry, on the slides. I'm looking for the Bugzilla. There is a public Bugzilla. If you are routinely seeing places where implementations differ and you file a bug, I can't promise we'll fix it tomorrow, but we do update the conformance test periodically. If we hear from many developers, this issue is a place where a lot of implementations are different or are broken, we can improve the quality of that. It's not a fast process, and I'm sorry about that, but it is something we take very seriously and want to improve. The test is good enough that nobody passes it the first time. So it does definitely catch bugs, but it only catches what it tests and it does not test everything. So I'll talk, well, let me ask you other questions, and then if not, we'll go into portability. Okay, so I actually had a dream about portability last night. I was not expecting it, but it happened. And in my dream, I was on this beautiful island, and I was having fun talking about graphics. And I had with me a beautiful API, which was elegant and small and powerful, and I could write really cool mobile apps with it. And I was happy, but I was not satisfied. So I looked out. I'm not making this up. I did have this dream. I looked out from my little island, and I saw a much bigger island to the south, where they were using a different API, which was similar, but not the same. And I looked east, and there was a very small island where they were using an API which had the same name, but was different. And way away to the east, there was a very strange group of foreigners who were using a different API still, and I was thinking, they're all doing cool stuff. I want this all to run on my API. How can I do this? Of course, this, silliness aside, this is a problem that we face every day. There are steps you can take to improve your situation. I didn't think too hard about this. This is probably not the right set, not entirely the right set of advice. For ES 1.1, of course, most platforms, if they support ES2, they also support 1.1, so you can just run them. If you want to do porting, sometimes you do, you want to enhance an application and you need to add features. It's much easier to go, in my view, to go from ES2 to 1.1, provided the shaders follow the model that is supportable in 1.1. If you're not doing something too clever, you can usually make that work. Going from 1.1 to 2.0, you have to replicate all the fixed functionality of the lighting and geometry pipe in software. There are packages on the web and reference code and things to help you do that, but still it's kind of an ugly problem. It's just being able to run things is nice, but that porting problem is not as elegant as it could be. For desktop GL, if you're writing new code, because desktop GL 2.0 and ES 2.1 and ES 2.0 are actually pretty tightly connected, pretty similar, it's pretty easy to find a common subset. You do have to read both specifications and have some testing issues, but you can write code that will run on both with very small hash defines. What's hard to do is to take a legacy application, some of these old X gears or whatever it's called, GL gears, and make it run on ES2 is difficult because it will use the legacy features which were removed, such as immediate mode, GL begin, GL end, if you know what that means. Replacing that manual is painful. You're basically doing what the driver used to do, because under the hood, the engine is really running something very like ES 2.0, very small, compact API, and in desktop GL implementations, all that old stuff is done in software. So you'll have to do that for the ES2 implementation. Direct 3D, it's quite difficult. Every line of your code has to change, and some of the model has to change. And there are some features we don't have, such as occlusion, counting the number of pixels rendered, which is a useful thing for doing dynamic occlusion calling. There are companies that specialize in helping you port or that write middleware that help support. Transgaming is one of them, but there are others. If you're working at that level, if you're working at a big game engine company, you are probably maintaining multiple render types anyway, and you're pretty much going to have to get into that level of work. It is not an easy thing to do, not for small companies. Meanwhile, back on the island, my beautiful dream was turning ugly, because I realized that my beautiful island was actually made up of a lot of small islands, and instead of one beautiful API, I actually had lots of implementations with my beautiful API, and they were all slightly different. And so code that ran very well on one implementation might run badly on another, or it might not run at all. And this caused me to wake up feeling bad, and leads to the rest of my talk, which is what can I do to minimize this problem? You cannot get rid of it, but what can I do to minimize the pain that I suffer? So I'm going to talk about, I'm trying to keep an eye on the time, why portability is a problem, if you didn't know. The key issues that I see, and again, I'm very eager to hear the key issues that you guys see, because I don't write code every day. I work on the standard, work on technology every day, and I'm sure you have things to teach me about where we could make portability better. But I'll give my view of the key portability issues and best practices for managing them. And by the way, interrupt. If I say something you don't agree with, just say, hey, I'm good. This is just my view, and there are many advanced issues and advanced ways of dealing with things that I'm not going to talk about. So earlier I said, you know, at SIGGRAPH 2010, I was claiming, hey, OpenGL ES 2.0 is everywhere. It's on all the major platforms. Well, Symbian is not major anymore, but it's on iOS, Android, WebOS. So why is there a problem? Well, is there a problem? Yes, there is. And the really embarrassing thing to admit is that we could have made it tighter than we did. We chose not to. And I'll talk about why. In Khronos, we're trying to maintain a family of standards that will live for a very long time until the models change so much that the standard doesn't apply at all. And to do that, we work in a space where there's a continuum, a trade-off between how portable is code, meaning how similar are the implementations, because that's what makes code portable, and how, you know, how much performance, how many features are available. If every implementation is the same, is forced to be the same, there's little opportunity. Well, actually, let me back up and explain it the way I wrote the slides. If we go hard into the, we want best performance, we want best features, and heck with portability, the limiting case of that is you don't have a standard API at all. You just have everybody builds a device, and they build an API which is optimized to express the power of that device. You do not get a viable business this way because no software developer can make money in this world. It's too expensive to port your code to 10 different implementations. So that doesn't work. If we go to the other extreme and we have perfect portability, this is the console model. If you are Sony Entertainment, perhaps you can do this. If you're Microsoft, perhaps you can do it. Most of us can't. If you mandate everything about the implementation, including things like performance, and people do ask us to do that. They say, hey, Khronos, you should have performance tests that verify not only that it gives correct results, but that it's fast. And we don't. And it's because of this. If you do that, you commoditize everything. The company that makes the cheapest implementation takes all the business. Everybody else goes out of business. And that company cannot afford to innovate because they have to reduce their costs to the absolute minimum. So this is great for one generation. That's why it's the console model. Everybody likes writing code. And what happens is, because innovation is like gas, it's like steam. It has to break out somewhere. It breaks out in a different API or in a different platform. And this API dies. So that model is not viable either. What we do in Khronos in general, but particularly in my working group, is we mandate minimum functionality that every implementation must supply, and we performance test that. But implementations have some degrees of freedom to add things, and they can do this in various ways, and that lets them innovate. And if their innovations turn out to be good, then the rest of the working group says, okay, next API, we'll make this part of the new standard, and everybody will do it. So you don't get perfect portability, but you do get a long lifetime. The one-slide version of everything else I'm going to say is just to say the specification tells you what every implementation must supply. So, and every implementation you work on is going to provide a superset of that. So the way to minimize your pain is to design your code to run in the minimum envelope that everybody supports. And then, if market forces demand, or if you've got time, you can say, well, for the most important platforms, maybe I'll do a little tuning and use some of these additional features. But only after you're already making money. So if that's enough, that's the baby version. You can quit or read email. But I'm going to talk now in more detail about specific issues that we see in support logs. The big three, I think, are performance portability issues. There are issues with non-standard implementations, that is, implementations exceeding a minimum. And there are issues with extensions. I should have put bugs here. There are bugs. Every implementation has them, and you do end up working around them. So talking about driver issues, performance, there are two kinds of issues. Part of it is the hardware, but I believe more of the issues actually come from driver behavior. The hardware is all, well, it's quite different, and you can see close to an order of magnitude difference in performance. But most of the performance differences you'll run into, I think, are due to the driver. So things drivers typically do that will drive you crazy. One is they're always trying to defer execution, do the thing where they're trying to hide from you when work is done and when is it not done. And they choose different solutions, but often deferring is the path to do that. And they'll do this to improve performance on average in their estimation of how you should write code. So for example, and sometimes it's driven by hardware, our architecture, the Mali devices and the imagination devices are tile renderers. That means that when you say draw, you give a draw command, well, first of all, nothing may happen. The system may just make a note that says, I was asked to draw this, and it will snapshot the data it's been asked to draw and put it on the shelf somewhere. And only at some point later, when it has enough work to be worth giving to the GPU, will it actually go and draw that stuff. This is usually okay, and their intent is you should not notice, but sometimes you do. This is particularly the case if the CPU is asked to do something, and it doesn't really do it, it just makes a note to do it later. And you keep on going along happily, everything seems very fast, and then you give one more command where you say flush or swap buffers to cause stuff onto the screen, and all of a sudden everything slows down, because now the CPU is going to do a lot of work, or the GPU is going to do a lot of work. That's a problem. Particular places where the CPU tends to defer work. One is texture upload. If you say text image 2D, maybe the CPU immediately goes off and creates the texture object, but maybe it doesn't. Maybe it doesn't actually create the texture object. Maybe it just copies the data and creates the texture object when you say draw. There are reasons for this. In some situations it makes things faster, but if it surprises you, it can hurt you. Compilation is another. Our implementations, when you say compile this shader, they compile the shader. But I know of implementations on the market that when you say compile the shader, they just snapshot the source code. And it's only when you say link or even use this program that they actually do the compilation. Compilation speed's an issue. All of the people making GPUs are good at making GPUs. I don't know any terrible GPUs out there. Not all of them are good at writing compilers. And so some of the compilers are much, much bigger, much, much slower than they need to be. We're proud of ours. We think it's very fast, and it fits in 200K or so on the Mali devices. But it's something to be aware of. There are big variations in this. And compilation speed can cause a noticeable hitch. You enter a new room, all of a sudden there's a new surface, and you have to compile a new shader in your engine, and suddenly you lose a thing, or you lose a couple. State changes, in particular, state dependencies are an issue. So when you say compile, you might expect that it will take a little while, a few milliseconds at least. It might surprise you, as I said, if the compiler seems to be fast, but then when you say link, that's slow, because it's really compiling that. There's another place where compilation happens where you did not intend it to happen. And this is if the hardware that you're running on has state dependencies. So for example, it's not uncommon for GPUs to do blending with software in the shader engine. And so if you build a shader, you say compile, the shader is now compiled, and now you change the blend state. The implementation may jump in and say, oh, the blend state that I compiled into this shader is now wrong, so I have to recompile the shader with the new blend state. Again, my implementation doesn't do this, but I know of implementations that do, and it can cause very unexpected performance hitches because say, well, I'm not doing anything yet the CPU is working very hard and I'm dropping frames. It can be because of this. The way you would get around that is to say, well, I'm going to compile a different program for every blend state that I'm going to use with this. You kind of have to read the documentation for the target GPU. they will generally tell you. So, no, I'm not going to name names. But the implementations I know that do this do tell you in the developer documentation, this is going to cause a recompilation. And you need to sort of know when that's going to happen and control it. Of course, there are hardware issues as well, particularly this distinction between tiling and direct rendering. Means that the actual rendering happens at very different times. Pipeline latency is different. And so the bottom line is, every implementation is different, and if you try to optimize for one, you are likely to be de-optimizing for another. In terms of best practices, there's lots of information on the web about how to optimize generically. For example, there are no implementations on which using vertex buffers instead of vertex arrays makes it slower, right? So unless you're doing dynamic texturing, but in general, do the things which will help you everywhere, such as using vertex buffers, such as using compressed textures. Beyond that, you do have to look at developer documentation for particular platforms, and you do have to test. There's just no way around it. I'm sorry about it. I don't know any way to help it. In the worst case, you end up doing what people do on the desktop, which is you have different code paths for different implementations. You query the device and say, oh, it's AMD, therefore I'm going to do things this way. That's expensive, and I wish it was not necessary, but if you want best performance, it's likely to be. So that's all I have to say about performance. Talking now about implementation-defined limits. I said the ES2 spec says every implementation must supply at least this. And in the back of the specification, chapter 6 is a table which you need to become familiar with, at least where it is, because it tells the minimums for all of the variable quantities that an implementation is allowed to support. So for example, how many textures can you have referenced by a single shader? There are guaranteed in ES2 that you can have at least 8, but some implementations give you more. And there's a query, there's a variable you can ask that says, how many textures can I have? Or how many vertex attributes can I have in this implementation? If you exceed the minimum, first of all, you must query to find out whether the implementation you're running on is going to be able to satisfy your need. Otherwise, it's going to give you an error and not render anything. And your customers will say, hey, your application doesn't run on this phone. Again, code to the minimum. So use 8 textures, use 8 vertex attributes. If you really want more, first query, see if you can do that. And if you can't do it, work around it, live with it somehow. Well, this is repeating what I just said. Stay within the standard if you can. Adapt if you must. The other thing you can do is say, well, I'm only writing for iPhone, and I know iPhone does this, or I'm only writing for Samsung Galaxy or something like that. But that's more painful, and it's probably worth a while to adapt. Another big issue is arithmetic precision. The language spec says that you can have these things called precision qualifiers, which, that is, all data types are either int or float in GLSLES. But you can qualify them by saying this is a low-p float, it's low precision. That means the implementation may, if it wishes, represent it as a 10-bit fixed point number. Or if you say medium p, you're allowing the implementation to represent it as a 16-bit floating point number, basically an EXR float. There is no default in the fragment shader. You are required to say what you want a float to be. No, I don't want to get ahead of myself. Right, the critical thing to know is that just because you ask for a low-p float doesn't mean you're getting it. You might be getting high-p if the implementation chooses to do that. So they can give you more than you asked for. They cannot give you less. However, in the fragment shader in ES2, support for High-P is optional. It's mandatory in the vertex shader. What that means is that if you write your code and you declare a High-P variable in the fragment shader, and then you try to compile it on Molly 400, or if you try to compile it on Taker 2, it may not compile. Or that's what the spec says it's supposed to do. It's supposed to fail and say, error, I don't support High-P. In fact, most vendors have found that it is essential to be able to compile, so they will silently give you medium P even though you ask for High-P, which violates the spec, but we have not been enforcing it because it seems better than to have the code run, even if it doesn't run the way the programmer intended. So, what do you do about this? First, you need to design your program. If you want it to be portable across implementations, you need to design it so that it works, even if you don't have High-P in the fragment shader. And the places where I commonly see, first of all, typically it is not a problem. Almost all fragment shaders do work fine with medium P. Where we do see problems, when we see them. The first one is with texture wrap factors. So if you're programmers, you know texture coordinates go from 0 to 1, 0 to 1 in 2D texture. And so, but they can wrap if you request it. So if I say, well, my texture coordinate starts at 500.3, and I read at 500.3, I'm actually going to get 0.3. But I still spent 9 bits specifying the 500. And that means that in a 16-bit float, where I only have 10 bits, I have no precision left to specify where I am inside the texture. So if you have big offsets on your texture coordinates, you are going to discover the limitations of 16-bit float. The other place you'll notice it is if you have highly specular mirrored surfaces with very smooth curves in them. Then you'll see the quantization. If you think about it, what is floating point good at? It's good at having a big, wide dynamic range. Well, when we're talking about normal vectors, which is what reflection vectors are, they all have length 1. So many of the bits of that floating point number are not telling you anything. Right? It's only the mantissa that matters, the exponent is irrelevant. The same deal happens with textures, that it's the mantissa that you care about. Sorry, it's the stuff to the right of the decimal point that you care about. Well, again, back to best practices, you want to use medium P when you can. Many implementations that do support High-P will give you medium P most of the time if you ask for it. Some of them are now doing optimizations where they dynamically decide to give you more. That can lead to unexpected behavior. You do have to test on implementations that don't have High-P. Otherwise, you're never going to know if the code's going to work. And right now, those are Tigra and Molly that are 16-bit float. There may be others I'm not aware. Imagination does High-P, and Qualcomm and Arduino does High-P. And I don't know what Vivanta does. Shading language issues. The language specification, which is a separate document, tells you what the language is in the abstract, in the ideal, what we would like the language to be. And then at the end there's an appendix which says, by the way, implementations are allowed to fail in these respects. And it says things like, if you use a very, very, very large number of variables, or if you use, if you write an enormous program, hundreds of thousands of lines of shader code, the compiler is allowed to fail. There are queries that will tell you something about the conditions. For example, how many uniform variables can you have? But it's actually quite hard to reason about those things. There are implementations which will not compile a loop if the number of iterations of the loop is not known at compile time. And I'm talking about major, serious commercial implementations, good hardware, they just have these limitations. You need to know what these limitations are, and you need to be careful about when you exceed them and when you don't. Most implementations provide, well, All implementations that I'm aware of provide a superset of the capability, but it's very hard to determine exactly what that superset is. For example, there is no query to tell you whether you can have a non-constant loop bound. We tried to write such an extension, and we worked on it for months, and we never got anywhere. It was just too difficult. And adapting to it would be difficult. So best practices, know what the guidelines are and stay with them, or write multiple versions of your shader if that's the way you really want to do it. But actually, this is one of the rare cases where there's a really good solution. All the vendors provide implementations of their compilers which run on desktop hardware. So as part of the build process for your game, assuming you're doing cross-compilation, developing on a workstation, and downloading to the phone, bring in all of these compilers, and when you hit build, just make sure you run all the shaders through the compilers, see if any of them fail. Yes?
I have a question on that. That also we have seen on the previous slide on test with the vendors' GPU solution or whatever they have, and especially offline shader compilers. I think that's very important. However, in my experience, it's generally hidden away or not easily accessible. I think, like for example, I think Adreno, Hong Kong, I need to go through a series of hoops to just sign up as a developer, etc.
Oh yeah.
Just to grab those stuff out, and all I want to do is, hey, just let me use the tool, if it's just so easy and you're providing it, why do I have to just go through so many hoops just to grab it?
Vendors do differ a lot in that, and it is frustrating to me also. I don't quite understand why it is that way. Again, a compiler, anybody can have it. Not the source code, but you can have an executable. But that doesn't solve your problem. One thing we have talked about, and we have never done this, but I would be interested to know whether you think it's at all useful. The thing is, we have talked about having a website at Khronos where behind the firewall we have all of the vendors' compilers, and we have a place where you can upload a shader and get back a report on the next web page that says you worked fine on these and you failed on those. The trouble with that is it's hard to batch, right? You can't put it in your build process easily. But
I think that shouldn't be too much of a problem. I mean, as developers, we don't mind signing up. That's not a problem at all. We just mind signing up for 4 different or 5 different vendors, each maybe using different names, different passwords, and then eventually you're just like, oh my god.
And you get updates.
There was one here.
Right. Yeah.
That's more. If there was a central repository saying, okay, sign up with Khronos.
Oh, right. That would be.
And that would be great. And
that would be even better, but that's not what I meant. What I meant was it would be a CGI script.
Right. Yeah, I understand that too. I think that kind of works.
Better than nothing?
It's better than nothing.
Better than the current situation.
Yeah.
Okay, that's good to know. I'll take that back to the working group. Okay, now I am well behind schedule, so Neil, I promise to finish up quick here. Another piece of advice and a request from our developer support people, please write good code. I don't mean fast code. What I mean is write correct code. We see lots of code that has bugs in it. For example, you have a draw call where you pass a vertex array and you don't initialize the pointer, but you also don't, sorry, I'm trying to remember the exact situation. It's like you have invalid pointers in vertex attributes which are instantiated but not enabled. So you're not pulling any vertex attributes from it. Some implementations will crash if you do that. Others will be fine with it. It is technically an error to have an invalid pointer in an attribute. Shading language errors. Some implementations, if you divide by 0, you get 0. In others, you get not a number. 0 may be fine. Not a number never helps. And implementations differ. So if you add 0 to not a number, what do you get? The spec doesn't say. The spec doesn't talk about not a number at all. but you will see differences in behavior. Just be aware that if you are potentially generating NANDs, potentially bad things will happen on some implementations, and different things will happen on others. It's basically undefined what won't happen. API restrictions, the spec says there are restrictions on the combinations of type, format, and internal format that are allowed. Some implementations allow more than that, even though the spec forbids it. And our conformance test currently doesn't test that. The Grand Unified test does, but the current test does not. And that means that a permissive implementation your code may run on when you move to a strict implementation. Copy text image 2D also has a similar issue. Extensions. OpenGL defines an extension mechanism which vendors can use to advertise new features. This is how they're supposed to. They're not supposed to just give you stuff silently. There's a query mechanism for determining what extensions are exposed. There are multiple classes. So an extension that is called OES something has been reviewed by the working group. It's been ratified, and there is a conformance test for it. So it probably works more or less as specified. EXT extensions are not ratified or conformance tested, but they're supported by multiple vendors who hopefully talk about what it means and agree. And finally, there are vendor extensions, ARM underscore, PBR underscore, etc. Best practice is not to use them if you can help it, because it's guaranteed. If portability is what you care about, you don't want to use them. Sometimes you have to, because you want the performance or you want the feature. Generally, if there are multiple versions, you probably want the OES one because it's most likely to be widely supported. However, when there are vendor extensions, sometimes it's because the hardware can't do the OES one. So, for example, RVR hardware cannot do OES texture and VOT, so they have their own version. But it is a subset of the OES extension. You have to query it, and you have to adapt if the extension's not there. We're so late, I think I'm going to skip talking about texture compression. You know, we are that far behind, we're not. Well, I will say this, the bad thing about texture compression is that texture compression is extremely important. This is one extension you do want to use because it has such an impact on performance and power dissipation. However, there is no compressed texture format that is available on all platforms. And so you are going to have conditional compilation and conditional asset development. ETC1 has some limitations. These slides will presumably be on the Khronos web, and there are various ways to work around them. Silent extensions. This is the issue that I talked about, for example, with vendors silently giving you more without having an extension string. They are not supposed to do that, but they do. And the conformance test in the past has not tested for that. We're starting to do that, and as we add new tests, typically we also test that it fails where it should fail. But right now, that's not comprehensive. The reason I hate this problem is that it's very difficult to deal with. The only cure really is to test everywhere, which I know you all love doing. You have to know the rules. If you find an implementation that does more than the spec says it should, please complain to that vendor and also tell me, and I will complain to them too. Get out the ugly stick. So in summary, portability is a big problem, and I'm really glad to have people here who know as much about it as you guys obviously do. It reinforces my belief in this. To some extent, it's not avoidable. It's the price we pay for rapid growth in the technology. Many of the problems are avoidable, and I and the working group are eager to help make things better. For now, you have to design for the core of the API and design for the minimum subset. That means you have to know what that subset is. Don't let the implementation tell you. Read the spec, read the man page. Get bugs out of your code. Don't do things which have undefined behavior, because that's where you are guaranteed to get different behavior on different implementations. and avoid implementation-specific features such as extensions, unless you really need them. And good luck. I got this information from, yes, I got this information from many people, some in the working group, some in ARM's developer support team, and other companies' developer support teams. I'm grateful for that. And I'm very eager to have feedback. Again, there's a public Bugzilla here, and you are more than welcome to put in a bug that just says, hey, I have noticed that I get different behavior out of this from every different implementation. And if it's clearly a bug in one implementation, probably tell that. But if it's clearly a bug in the conformance test, because it's not enforcing consistent behavior, tell us. Again, we'll try to fix it when we can. Any other questions or comments? Thank you.